In this lesson for 6.3, we're going to use a theorem called the binomial theorem, which is going to help us expand any binomial to some degree. The goal is that we're going to use Pascal's triangle to help us with this. But let's take a look at getting the answers without using Pascal's triangle. All right, so for example, if they gave me a binomial a plus b to the 0, I know that's going to equal 1 because anything to the 0 power is always 1. Let's say they take the binomial to the first degree. I know that that's still just going to be a plus b. Yesterday we talked about that if we had a binomial squared, that the result was a perfect square trinomial. Okay. Let's look at if they gave me an a plus b to the third. And so I've kind of already set this up a little bit for us. An a plus b to the third means you have 3 of the a plus b's. Well, 2 of them is that binomial squared, which was that a squared plus 2ab plus b squared. But then I still have to take that times the other a plus b. So I made the box method just to help organize my information. So here's my a, there's 2, and there's 1, so there's 3 of them. If I want to multiply these two together, I'm going to have a 2a squared b. Here, I'm going to multiply them together, and I'm going to have an ab squared. Next one, again, I'm going to have an a squared b. Next product is going to give me a 2ab squared, and then last I'm going to get the b cubed. All right, so I'm going to write my answer as a to the third. And then I've got my a squared b, and here's another a squared b, so that gives me 3a squared b. And then I'm going to look at the ab squared. So I have 3 of those. And then last I have the b cubed. Okay, so I'm going to write that down here. So I have a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay. Now let's look at an a plus b to the fourth. Okay. Well, that's meaning I have 4 of the a plus b's. This is the same thing as an a plus b squared, which we've already stated is a squared plus 2ab plus b squared. Here's another a plus b squared. Okay, so I have another a squared plus 2ab plus b squared. Okay, so since I have a trinomial times a trinomial, I know I'm going to have 9 distributions. A squared times a squared is going to give me an a to the fourth. Multiplying these together, I have 2. That's going to give me an a to the third and then a b. Here I'm going to have a squared b squared. Here I'm going to have a 2a, that's going to be 3 a's and a b. Here I have 4, that's an a to the second, b to the second. Multiplying this and this one together, I'm going to have the 2, the a, and I have 3 b's. Looking here, I've got the a squared b squared. Looking at this one, I've got a 2, I have an a, and then I've got 2 and a b, so that gives me 3 of them. B squared times b squared is a b to the fourth. So let's clean this one up. This one gives me an a to the fourth. Then I'm going to look at my a cubed b's. There's another one. So I have 4 of the a cube b's. Then I'm going to look at the a squared b squared, which are all on this main diagonal. So here's 1, there's 4, there's another one, so that gives me 6 of the a squared b squareds. Okay, so then I'm going to come look at the ab cubes. So there's 2 and 2, so that gives me 4 of the a b cubes, and then last I have the b to the fourth. Okay. So as you can see that every time they up the degree, it makes your distributions bigger. Okay, not that you can't do it, but it just gets really time consuming. If they told me to take this to the 12th, that would take forever to do. Okay, so that's where the Pascal's triangle is going to come into play to help us out a little bit. So an a plus b to the fourth, simplify down to a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. And again, I could keep going with this, but I want you guys to see a little bit of a pattern here. So, looking at our patterns, when we have a binomial to the nth degree, if we look at the exponents of a, all right, so first of all, there's no a here, but here's an a, that one's to the first. Here's a a, okay, then this a, then we've got that a. But then let's look at the a. So here this one was a fourth degree, that one was a third degree, that one was a second degree, that was a first degree, and then there are 0 a's here. So when it says the exponents of a, well, what are they starting at? So for example, this one starts off a to the fourth because it was a fourth degree. This a starts off at a 3 because it was a third degree. This a is a squared because it was a square degree. So the exponents of a are going to start at whatever the n is, whatever the exponent is. And then it says they're doing what by how much each term. So for example, I've got an a to the fourth, then a cubed, then a squared, then an a, then no a's. A cubed, a squared, a, no a's. So my exponents are starting off at this number, and then they are starting to decrease by 1 each time. Then it says, well, let's look at the exponents for b. Well, starting off, there are no b's here, but then there's 1b, then there's 2b, then there's 3b, then there's 4b. Looking here, there are no b's, but then there's 1, then there's 2, then there's 3. So the exponents of the b's, there are no b's starting off, so the b's are starting off with 0 exponents. But then the b's are starting to increase by 1 each term. And then if we look at the sum of the exponents of each term, well, these exponents add up to 4. These exponents add up to 4. These exponents add up to 4. There's a 1 here. They add up to 4. And there's 4. Okay, so they're all adding up to 4 because it's a fourth degree polynomial. This exponent is 3. If I put a 1 there, those add up to 3. If I put a 1 there, they add up to 3. And that one's a 3 because it is a third degree polynomial. So the sum of the exponents of each term is whatever the exponent is. Okay, so then it says the coefficients of the terms in the expanded form of a plus b to the n are the values in row what of Pascal's triangles. So we'll come back to this. Okay. And then this question says there will always be what terms in the expanded form of a plus b to the n. So they gave me a fourth degree polynomial, they gave me a fourth degree binomial. Let's look at how many terms that gave us as an answer. So here's 1 term, 2, 3, 4, 5. So when they had a fourth degree, I had 5 terms. Let's look at the previous one. This is a third degree this is my third exponent, but I have 1, 2, 3, 4 terms. Here is to the second power, but I have 1, 2, 3 terms. This was to the first, but I have 2 terms. This one was to the 0 exponent, and we only had 1 term. So there will always be one more term than the exponent. Okay, and again, we're going to come back to this. So Pascal's triangle is a really famous triangle that has a pattern to it, and the numbers are going to help us out with our expansions so that we don't have to do all of this stuff. All right, so looking at Pascal's triangle, they start off counting row 0. Row 0 is going to have a 1. Row 2 is going to have a 1 and a 1 as well. Okay, not enough to let you know of a pattern yet. If I look at row 2 is the numbers of 1, 2, and 1. Row 3 has a pattern of 1, 3, 3, 1. So maybe you're starting to see a pattern. And there's a bunch of different patterns, honestly. Let me do a 4th row. Here I have 1, 4, 6, 4, 1. Okay, so again, hopefully you can see a row. Or, I'm sorry, maybe you could see if you could do row 5 on your own. If not, it's 1, 5, 10, 10, 5, and 1. So see if you can predict row 6. And if you can't predict all of it, see if you can get some of it. Okay, so one thing that I'm seeing is that this is always a 1 on the outside. And this is always a 1 on the outside over there. Now some of you might be seeing like, hey, there's 1, 2, 3, 4, 5. So the next number maybe you're predicting is a 6. That is correct. 1, 2, 3, 4, 5. Next number is a 6. Okay. But the pattern to help you predict the next row is 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 3 is 6. 1 plus 3 is 4. Okay, so if I want to find the next number, I'm going to look at the 2 numbers above it and add it. So that's going to give me a 15. Looking at these 2, that's going to add up to be 20. These 2 are adding up to be 15. You can also see it's kind of like a reflection as well. So I could keep doing this. I could say, well, what's row 7, what's row 8, and we can keep extending this out. But hopefully now you can see a little bit of a pattern. And then let's go back and look at the previous page for your notes. If I take a look at this, here I have a 1. Here, look, I've got a 1 here and a 1 here. Then I have a 1, 2, 1. Here I have a 1, 3, 3, 1. Here I have a 1, 4, 6, 4, 1. And if you notice, those are the same numbers as Pascal's triangle. 1, 4, 6, 4, 1. So Pascal's triangle is going to help us to figure out the coefficients for the numbers in front. So here's 1, 3, 3. Here was another 1. Okay. And if you look, the degree was the row that I had the coefficients. Here was my exponent here. Okay. So I've got a 4th degree. So I could look at row 4, and I could see that I'm going to be using a 1, a 4, a 6, a 4, and a 1. Those numbers came into play. Those are the numbers in front of the variables. Okay? So we're going to use Pascal's triangle to help us expand our binomials so that way we don't have to distribute like crazy. So first of all, you guys got to identify the values in row n of Pascal's triangle. So whatever the degree of the binomial is, you're going to go to the row and you're going to know that these are the numbers in front of your variables. Okay. The next thing is you're going to identify the A and the B in the binomial. So like what's the first term in the binomial? What's the second term in the binomial? Okay. It says, remember, your first term has the A to the nth power. So the A always starts off to the nth power. And the B is always starting off to the 0 power. So as you move to the next term, the A exponent will decrease by 1, while the B exponent will increase by 1. Okay? And then we're going to simplify. All right, so I've got a few examples for us. I can do an x minus 5 to the 4th, which here was an a plus b to the 4th, but you can see I've got all of this work to do, which I don't want to do that. Then they're giving me a 5th degree later on, and then we even have a 6th degree. We don't want to have to distribute all of that. So what we're going to do is first off, we're going to figure out our coefficients. So because it is a degree of 4, and remember Pascal's triangle, this is row 0, this is row 1, this is row 2, this is row 3, this is row 4. These are the coefficients that I need to use. Oh, we can't see that, I'm so sorry. So row 0, row 1, 2, 3, here's row 4. I know that these are going to be the coefficients in front of all my variables. So what I will do on this is I will write out, okay, I know I'm going to have a 1. I'm going to give myself some space because I'm going to have variables back here. I'm going to go ahead and put the 4. Then I'm going to put the 6. Then I'm going to put the 4. Then I'm going to put the 1. Okay. So first thing is identify your row. We were in row 4, which told us to use the 1, the 4, the 6, the 4, and the 1. Now second thing is you need to identify your A. Our A in the A spot is the X. Okay. So I know that the A term always starts off with the degree. So it's going to be an a to the 4th. And then it said on each term, that's going to decrease. So I'm going to decrease the A's. Then for my B term, which is the -5, get a different marker here. The B term starts off at 0, and then it increases by 1 each term. Okay, so we're adding, these were all positive numbers. Let me go ahead and put those in between there. Okay, so now we need to simplify. -5 to the 0 is 1. Anything to the 0 is 1. 1 times x to the 4th gives me an x to the 4th. Okay. Here I have -5 to the 1st times a 4, so that gives me a -20. And then the x is cubed. Looking here, I have -5 squared, which is 25, and 25 times 6 is going to give me 150, and then the x is squared. Okay. Looking here, I have -5 to the 3rd power, which is -125, and then I need to take that times 4, so that's going to give me 500 x. And then last, I need to take -5 to the 4th times 1, This is also a 1 because it's to the 0, so that is going to simplify to 625. And there's our binomial. And we didn't have to do all of this stuff. Okay, so let's look at another example. First thing, figure out what your coefficients are going to be. So we're going to be in row 5. All right, and row 5 is going to have the coefficients 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, and 1. Okay. Next, I'm going to figure out what my A is. So on this one, our A term is the 3x, and our B term is the 4. Okay, so starting off, we're starting off with a 1. The A term, or the first term, is always what the degree is. And the second term, the B, which is 4, is to the 0 term. Okay, so now moving on to the next coefficient, so we're going to have 5. Remember that these will start to decrease in exponents. Those will start to increase. So I'm going to say 3x is now to the 4th. But the 4 is starting to gain. Okay, my next coefficient, I've got 10. Our 3x, 5, 4, it's descending. But the blue terms are starting to increase. So that should be to the second. I know I have another 10. Again, 5, 4, 3, so this 3x is to the second. Zero, 1, 2, and you got your 3. Okay, now we're going to go with our next term, 5. Our 3x is decreasing, so now that's at 1. Our 4 terms, exponents are increasing. Remember, these should always add up to the degree. And then our last one, we have the 1. The 3x is to the 0. And the 4 is to the 5th. Okay, so now we need to simplify all of this. And it's still faster than doing it by hand. Okay, so 4 to the 0 is 1. Okay, but if you look here, I've got a 1. 3 to the 5th. So you've got your 3 times your 3 times 3 times 3 times 3. And that's going to give you 243. X to the 5th. You can say times 1. Moving on to your next term, we have a 5. 3 to the 4th, so 3 times 3 times 3 times 3 is going to give you 81x to the 4th times a 4. Okay, next I've got the plus 10. 3 cubed, 3 times 3 times 3, 27x cubed, times a 4 squared, which is 16. Okay, so then I've got plus, here's my 10. 3 squared is 9, so I have a 9x squared. 4 times 4 times 4 gives me 64. I'm going to say plus 5 times 3x to the first is just 3x. 4 to the 4th is going to give us 256. Okay, then I'm going to say plus 1 times, this is a 1 because anything to the 0 is 1, and then a 4 to the 5th is 1024. And then again, we need to keep simplifying that. So 1 times 243 times 1 is 243x to the 5th. Okay, then I'm going to do 5 times 81 times 4, and that's going to give me 1,620 x to the 4th. Okay, then I'm going to say plus, I'm going to do 10 times the 27 times the 16. That gives me 4,320 x cubed. Okay, next we're going to do 10 times 9 times the 64. That's going to give us 5,760 x squared. Then we're going to do 5 times 3 times the 256. That gives me 3,840. And then last we have the 1 times 1 times the 1,024. Okay. All right, for tomorrow we'll look at these last two examples.